Hi friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another interesting array coding question on Leetcode 2908 minimum sum of mountain triplets 1. So this is another quite interesting problem to solve on Leetcode. I wanted to show you the logic as well as how to efficiently solve this coding problem. So we'll go through some examples, understand the logic clearly so that you can uh, understand this problem, and we are also going to write and implement our Java solution code. If you are new to this channel, please subscribe to this channel now. This really helps and supports this channel. On this channel, we create videos to help others in their Java and coding interviews, and you will see more than 500 different varieties of coding problems solved and explained on this channel. Check out the playlist. You will see all important question varieties here that includes graphs, matrices, binary search trees, different traversal techniques such as BFS, DFS, dynamic programming, memoization, recursion. You can also use this channel to learn more about how to use data structures to solve problems such as stacks, queues, priority queues, min heap, max heap, hash set, hash map, and a lot more. So do check out the playlist after you watch this video, and let's start with this problem statement. You are given zero indexed array nums of integers. A triplet indices ijk is a mountain if I is less than j is less than k, right? And the second condition is nums of I should be less than nums of j, and nums of k should be less than nums of j again, right? Then it will form a mountain basically. Return the minimum possible sum of a mountain triplet of nums. If no sum such triplet exists, then return -1. So this is what the problem statement says. We will understand it with some examples. Constraint says that the nums dot length will be between 3 to 50 inclusive, right? So in that array you will get 3 or maximum 50 elements basically, right? And the element itself will range between 1 to 50 inclusive. So let us take a look at some examples. So let's say this first example, right? So in the first example, 8, 6, 1, 5, 3 are the numbers that are given to us, and they are saying that the triplet at index 2, 3, 4, right? 2, 3, 4 is this one. So 2, 3, 4 is 1, 5, 3. So you can imagine that it's a kind of a finding mountain basically, right? And the sum of them we have to return. So 5 plus 3 plus 1 is 9. So that's what the answer is. So this is the minimum sum triplet. Okay, so we have to find minimum sum because there can be multiple triplets in the example, right? So this is one example where you will see multiple triplets. So what kind of triplets are we seeing here? So let us see, right? So for example, I can see a triplet 5, 7 and 10, 5, 7 and 2. So this can be one triplet, right? 5, 7, 2. Why it is a triplet? Because if I draw, let's say if I draw something like, for example, a graph, then 5 is here, 7 is here, and 2 is here, right? So if I do something like this, then it will create a mountain basically. So it is a mountain triplet, right? So there can be multiple like this here. So for example, I shown you 5, 7, 2. You can see that there can be multiple here. So another can be 8, and then you can 4, 8 and 2. This is another triplet, you can see there, right? So it is 4 and then 8 and then 2, right? So if you again draw, then it will look like this, right? 4, 8 and 2, right? So again it's kind of a mountain basically. So they call it as a mountain triplet. Okay, so now you understand what that mountain triplet is with this. But now the problem is that there can be multiple triplets, right? In this example itself, we have seen multiple triplets, right? So our goal is to find out a minimum sum, right? Minimum sum. So for example, if you sum this one, it will give you 14, right? If you sum this one, it will again give you 14. So our purpose and goal for this is to find out minimum sum mountain triplet. So brute force way, if you do it, then you keep checking mountain triplet for all possible combinations, right? But that will be overkilling, right? So because checking for each possible combination will be overkilling, so we have to find out a better way to solve that problem, right? So you must have noticed that when we say that it's a mountain triplet, then you always, for example, let's say 4, right? 4 and then 8 let's say, and then 2. So this one is your mountain triplet that you can see here, 4, 8 and 2, right? Okay, so we know that it's a mountain triplet. So what property makes it a mountain triplet? So if you look at this one, then you will see that on your left side a number is smaller than this number, 4 is smaller than 8, and on your right side number is also smaller than 8. That makes it a mountain triplet, correct? That's how we recognize that it's a mountain triplet, right? So we can use this property actually to solve this problem in a better way, right? So how, if we know for each index, right, what is the smallest value, for example, so if I am at this index, right, 8, and if I know what is the smallest value on my left side, right, and what is the smallest value on my right side, right, then I can find out a triplet basically, which is with a minimum sum, right? So the same example is taken over here. So this is the same example, right? So this is the array which is given to us. So what we can do is we can create one array called as, we'll call it as a left, right? One is a left. So first understand what that left array is, right? So for each index, I want to find out what is the least value on my left side. For example, I am here, right? I want to find out what is the least value on my left side, including where I am. So including where I am, least value is 5 here, right? On the left side. Okay, left side. When you go to 4, what is the least value on the left side, including 4? Including 4, 4, right? So you put 4 here, right? So when you go to 8, what is the least value on my left side, including 8? 4, right? So similarly, you will put here also 4, here also 4, right? And when you go to 2, what is the least value on my left side? So you have to understand that least value including 2 is 2. So you put 2 here, right? So this one will tell me for each index what is the least value on its left side, including that index value, correct? Okay, so this part is clear. So we'll create one left array and we will create another array called as right array. So what is right array? So right array will be similar. So for each index I want to put what is the least value on my right side. So when I am here, what is the least value on my right side, including 2, right? Okay. When I am here, what is the least value on my right side, including 2? Again I'll put 2 here, right? Okay. When I'm here, 7 again 2, for 8 again 2, for 4 again 2, and for 5 again 2, right? Least value on my right side. So wherever I am standing, I want to see least value on the right side basically. So I have two arrays now. One is my three arrays. One is my original array, one is my left array, and one is my right array. So you understood what the left array is and how we populated that. So first try to understand this logic. Okay, the implementation is not that big of a deal. So now you go to the right array, you have two arrays. So why we create this, right? Why we create this is because we can now identify a mountain, right? If I am standing here, then I can check on my left side index what is the minimum possible value on my left side is given here, right? So I know that there is a value on the left side which is 4, right, somewhere. We don't know exactly, but we know that minimum value on my left side is 4, and I also know that minimum value on my right side is 2. Somewhere it will be there. So you can see that it's here. But this minimum value I can find out by using this left and right array for my current index, correct? So if my current index 2, I will have to go 1 here and I'll have to go 3 here basically, correct? To identify the minimum value on the left side, I will go I minus 1, and identify minimum value on the right side, I'll go I plus 1, correct? And I know these values now. So it means that if I take these values 4 and then 8 and then 2, then it gives me a mountain basically, correct? You can see that it's a mountain, and then I will calculate its sum. So it's 14, right? And I will keep tracking whatever is my sum is. I will keep track of that minimum value, because I want to find out minimum value here, right? So this is for 8. So similarly you will do for every index, right? So when you go to 7, this is where you will find out the minimum sum. What you will check, you will check the value I minus 1 in the left side, and you will check the value I plus 1 in the right array in the right side, I plus 1, right? So it means that you have a mountain array there, right? 7 4 7 and 2, correct? 4 7 and 2, 4 7 and 2 is your mountain array that you find at 7, right? And its sum is equal to 13, correct? So this is the minimum sum that you will find basically, right? So as you can see here in the example, 13 is the answer, right? So this is how the 13 came basically. So for each index you will keep checking. If it's a mountain, then what will be the minimum possible sum, right? And then you will just get the answer basically, correct? So this is the way you can effectively solve this problem, rather than going a brute force way where you have to check each triplet. That will be overkilling. So this is a much better approach. So you understood why we did this, right? The logic, the left side will tell me whatever is the minimum element on its left, right? So if I go here and check, this one will tell me whatever is the minimum on the left, 4, right? And if I check that right array, it will tell me whatever is the minimum element on its right. So the minimum element is 2, right? Wherever it doesn't matter basically, because it's a still mountain triplet basically, right? It's a mountain triplet, correct? So this is why we have done that left and right arrays, right? So we'll just kind of do some pre-processing, get left and right arrays, then apply this logic to find out the minimum triplet sum, correct? So now let's think about the time complexity. So here you have to go completely n times. So this is order of n. Again you will also go n times here, order of n, and again you will loop through the original array n times. So it is order of n, but you have to remember that these are separate, right? So it means that your time complexity will be order of n, correct, for this one, which is a far better than doing a brute force with the order of n cube. So let us take a look of how to implement this. So once you understand this logic, what we are doing here, then it's pretty easy. So minimum sum is what we are implementing. Nums array is coming to us as an input. This method returns int, right? So first you will calculate the nums dot length into n. We'll create one variable answer and we'll assign it with a max value because we want to find minimum value, right? We'll create two arrays as we discussed. One is left array and one is right array. Both will have size n, right? And we'll just assign left 0 is equal to num 0, because we know that there is no left side element for 0 element, right? Okay, and here you will go from 1 to n. Remember, you are starting at 1, right? Because you know that for the 0th index there is no left element, and here you are calculating the minimum element basically. So mat.min between your left of I minus 1 and current number, you will take that minimum between these two values and assign it to left of I, correct? So this way you will get this left of I array, right? So this is exactly what we are doing here in this for loop, right? After that you have to now also get the values into your right array, right? So right n minus 1 is equal to nums of n minus 1. Why? Because you cannot go on the right side of the last element. This is your last number, there is nothing on the right side, right? So that's why. After that you will start iterating from I is equal to n minus 2, I is greater than equal to 0, I minus minus, and you will start populating the right of I. With the value, you will have to take the minimum value between right of I plus 1 and nums of I, right? Whatever is the minimum value, you will have to assign it to your right of I, and it will tell you for your current index I, whatever is the minimum value on your right side, basically, correct? So you have populated both your left array and right array in this for loops. Now is the time to check for the actual mountain triplets. For that we have to go through the original array, right? So I is equal to 1, I is less than n minus 1, I plus plus, and then we have to keep checking, right? So you will check on your left side and on your right side where you are currently standing. So you will, if you are at I, then your left side is I minus 1, correct? So you will check I minus 1 if it is less than your nums of I, right? I minus 1 is less than nums of I, and right of I plus 1. So it's a right side index of your current index I, right? If it is less than your current index value, nums of I, it means that you found out a mountain triplet. If you found out a mountain triplet, then you want to calculate its sum and check with your answer, right? And take the minimum of it. So that's what you are doing here. Mat.min of answer, left of I minus 1 plus nums of I plus right of I minus I plus 1, right? So it will give you the triplet sum, and you will take the minimum because there can be multiple triplets, and store it in answer, right? At the end, you will just check if your answer is integer dot max value, which is your original value that you assigned here. It means that you did not really find any triplet, right? It means you did not find any triplet. In that case, you will return -1. Otherwise, you will return your answer. So this is the way the code goes. The code is very simple to understand once you understand the logic behind it, right? So for loop, and for loop again, but all are separate for loops. It means that your time complexity for this code is order of n, and your space complexity for this code is again order of n, because we have a left and right array of size n, right, which is a space basically. So we'll run this code against the test cases, make sure the code works correctly. And as you can see, the test cases are passed. So we'll submit this code now to the Leetcode and make sure the code gets accepted by it. And the code is accepted 99.67% faster than other submissions, which is a very good solution to solve this problem. 2908 minimum sum of mountain triplets. So here we have done some pre-processing logic as I shown you here with left and right. So make sure you understand this pre-processing logic. It also helps you with some other array problems. And try to also implement your solutions. So if you like this video, if this whiteboarding session and examples that we explained help you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. The subscriptions are very important. That helps and supports this channel. Also share these videos with all your friends, so they will also come to know about this channel. They will also watch and learn from these different varieties of good videos that we keep creating for you. More than 500 solved problems are here for you. You can use this channel to learn more about algorithms and data structures. Different algorithmic problems that includes trees, graphs, binary search trees, matrices, strings and array problems are available for you here. You can also learn data structures such as stacks, queues, priority queues, min heap, max heap. Also, you can learn the dynamic programming, memoization, recursion using DFS and BFS. So do check out those videos. They will definitely help you a lot in your interview preparation process. Keep learning, keep coding, keep solving different varieties of problems so that you can sharpen your algorithmic skills, and will definitely help you in your interviews. And thanks for watching this video, and have a great day ahead.